Hello everyone. So today we're focusing on Cambridge IGCSE Mathematics, topic of number, subtopic estimation and rounding numbers. So to start off, we're going to discuss about what is estimation. So estimation is basically trying to find out the rough value of a calculation. So when things are difficult to calculate in our head, or when it is difficult to do the mental math, we try to round the numbers in a way that we can calculate a rough answer, which is close to the actual answer but not accurate. And we sometimes tend to use that even in our everyday life when we go shopping and we try to just calculate the rough idea of how much we've spent on our grocery list. Well, it's difficult, right? We can't do the exact numbers in our head. Some of us might need a pen and a paper to jot down the answers. So how do you estimate? Now, for example, if you see this, Ray and Jane, they're collecting marbles, and we know that Ray has 337, Jane has 443, and we want to basically estimate how many marbles they own together. Yes, this one's easy enough. We can just add the numbers. But if I want to make it simpler and do the addition a little bit more simply, what I could do is rather than taking it as 337, I could estimate it to 340. And rather than taking it as 443, I can take it as 440, as you can see here. And then simply adding 340 and 440 gives me 780, which is my estimated answer, right? And then what we could do is also something called rounding, right? So the rounding is basically you can round all types of numbers. So first thing we're looking at is rounding to the nearest integer, right? So when you have a decimal number and you want to round it to the whole number, what you have to look at is basically you have to look at the first decimal point. So in this case, the first decimal point is an 8. And always, if you have 5 or more, you have to round up. And 4 or anything lower rounds down. That's the rule of thumb. So here, since I have 8, which is more than 5, the next number, which is not the number to the right, it should be to the number to the left, has to go up. And in this case, so 152.8 rounds up to 153. Moving on, if you see that I want to round, for example, to one decimal place, so I have to basically look at the next number. So I'm rounding to one decimal place, so I look at the second decimal point, right, which is a 3. So remember, we have to round down. So when I round down, the answer remains as 152.8. If, however, my number was 152.85, then this would have rounded up to 152.9. Okay, so that would have been the difference. And if you look at the two decimal place one, so I have to look at the third decimal point number here. And because this is a 6, you can see that the 83 has changed into 84. And that's as simple as it gets. Rounding, one of the easiest techniques that we do in mathematics. And then the rounding that basically certain children find a little tough is rounding to significant figures. So here we are, significant figures, and what do we count as significant figures? So if you have something like 5,263, the 5 is considered the first significant figure. But if you have a decimal value such as 0.00312, then the 3 is considered the first significant figure. Okay, so basically the first non-zero digit that you see is considered as the first significant figure, right? And of course the second would be the one after that, and the third would be the one after that. And that brings us to the end of rounding and estimation. Let's look at a few questions. All right, so we start off with the first question. What is 3.5175 rounded to two significant figures? So when we are looking at the second significant figure, which is 5 in this case, we have to look at the number next to that to decide whether we have to round up or down. And we have a 1 next to that, which means we have to round down. So hence the solution for this one will be 3.5. Moving on, estimate the value by rounding each value to the nearest first significant figure. So we can try and summarize this question in a way that it's easy for us to solve the problem. So if I look at basically this square root value here, so I'm going to make the top close to 100 because 98.7, the closest first significant figure, I think will be 100. Since the denominator is a square root number, I think it's easier if we take square root of 81 because that is close to 9. And here we can take it as 30 instead of 31.9. And basically we can make this as 10. So going from here, so 30 squared is basically 900, right? So 900 in, and then we have the 9 coming from here. So that's going to simplify this to basically another 100. So that's going to be 100 into 100, which is basically 10,000. And ideally you can even omit this plus 10 here because it's just very small in comparison to the large values that we're dealing with. So we will go for 10,000 here. The number of people at a party is 300 to the nearest 10. What is the greatest possible number of people at the party? Okay, so if we have rounded to 300, then we can round down or round up. So they're asking the greatest possible. So that would be basically somebody like 304.9 odd. So we usually take it as 305, which is the upper boundary. And finally, write 28.07546 correct to 2 decimal places. So we look at the third decimal place number and we can see that it's a 5. So that's going to make us round up. So the answer is going to be 28.08. And that brings us to the end of this lesson. Join us for the next one.